In question 7, we get introduced to our hyperbolas. Now, Kev, yes, my brother, how do you know this? It's because x is at the bottom of the fraction over here. And I can tell a lot about this function just by looking at it. So if I analyze the a value, that number on top, I can see it's positive, so it's going to be in these two quadrants. If I analyze this number at the end, that is going to be my horizontal asymptote that goes left and right. And if I analyze this at the bottom over here, that will be my vertical asymptote. Just remember, it must be the opposite sign if it's in standard form. And from that, the equations of the asymptotes, this equation here, y equals -1, and it's this one here, y equals -4. And you can see here, asymptotes, plural, it implies there's more than one. And your 2 marks come from each equation. So next up, I need to calculate the intercepts of the graph of f with the axes. So I'm going to grab this equation of f of x, and we're going to start working on the intercepts. Now to get intercepts, you make the other guy equal 0. So if I want the x-intercept, I make y equal 0. And if I want the y-intercept, I make x equal 0. Let's start off here with the x-intercept. F of x is a fancy placeholder for y, so I'm going to change f of x to a 0, just like this. You can see how this f of x replaced with Kanda Mababa. Next up, we're going to grab that -1 and move it over to the other side of the equation. And just remember, when you do that, it's going to turn into +1. And now we can start the process of cross multiplication. So I put 1 over 1, and then I grab the bottom, take it up and multiply. And then 1 times that bracket won't really change anything. So I'm just going to get x plus 4 on the left hand side, and it's equal to 2. It's equal to what's left over there. Or you can say 1 times 2 gives you this 2. And then we're going to yoink this +4 over. Bear in mind it becomes -4. 2 minus 4 will give us -2. And after you have that -2, just make sure you write the full coordinate like this. -2 with the y value of 0. And then the y-intercept is a lot easier. We just make x equals 0. So we change this x in the equation to a 0. And then we just pop that in our calculator. How convenient. Okay, so we just pop that in, press equals, and it gives us -1/2. So always remember, write the full coordinate under that for the y-intercept. Over here you have an x value of 0, and whatever y value you calculate goes in this place for the y value. And your 3 marks in this question are earned from making y equals 0 over there, this x value and this y value. In question 7.3, we are asked to sketch the graph of f, clearly showing the asymptotes with the axes, the asymptotes and intercepts with the axes. So let's see what we know about this graph. We know a lot already. We know where all its intercepts are, all its asymptotes, as well as a is positive, so it's going to be in those 2 quadrants. So let's get a Cartesian plane going. We'll start off by getting our asymptotes in. So this asymptote will go at -1. It's going to go across like this. So it will look something like this over here. Now let's do the vertical asymptote. It's going to go up and down. It's going to be at -4, so quite a way out, like over there. So it will look something like this. Okay, let's get our x-intercept and y-intercept on here. Our x-intercept will be like halfway in between over there. And our y-intercept will be at -1/2, so it will be above this line over here. And then we can just sketch in our 2 curves. And now we've successfully done everything they've asked. We've marked off our asymptotes with these labels here, marked off our intercepts with these labels over here, and we've successfully drawn it with the right shape. And that's exactly where your 3 marks will come from in this question: shapes, intercepts, as well as asymptotes. In question 7.4, we are getting the image of the x-intercept if it's reflected about the axes of symmetry, which has this equation. So let's see where that is going to be. So I've represented the axes of symmetry with orange. So this orange line here is that axis of symmetry they're referring to. Now I'm going to take this x-intercept, reflect it over that line to find the image down here. And how we do that is with the following strategy. Whatever distance I go left to this asymptote, I do that same distance to go left there. So to go from -2 to -4, I'm going 2 units across over there. So I've got to go 2 units across over here, and I can get my x value to be -6, because I'm going from -2, and then I go back 2, back another 2, and then I get to -6. And there's a very similar process with the y value. If I go down 1 over here, I'm going to have to go down 1 over here to find my y value to be -2, because I start at 0, go down 1, go down another 1 to get to -2. So this coordinate they're asking for is -6 and -2. And you will simply just get 1 mark for your x value and 1 mark for your y value in this question. In question 7.5, we need to write down the range of y equals minus f of x. Now that minus in front of f of x is telling me there's a transformation at play over here. And if we have a look at the relevant transformation rule, when you have this notation, sort of a new function equals the old function with a negative being multiplied in front, that is a reflection over the x-axis. So we're going to take this graph and reflect it over the x-axis. And our new graph will look something like this. It's going to place our horizontal asymptote at +1, and that will definitely have an effect on range. So let's start structuring our answer now. So range tells me where the graph exists, and it deals with y values. So we're looking at our y values. So this graph exists at all y values except this y value here of 1. So how we state that in maths is we say y is an element of real numbers. That's saying y exists everywhere. We put a semicolon next to that. And then we state that y cannot equal -1. And in summary, what that says is y exists everywhere, but y doesn't exist at -1. At +1, sorry. It's an asymptote. The graph never ever touches that y value. And you just get 1 mark for the correct answer for this question. Slagbot. Next up, we have quite a difficult question. Describe the transformation of f to g if they give us the equation of g of x to be this. So what we need to do is look at our original equation, and then we grab this new equation and we ask ourselves, how did we get from the original one to this one? So you kind of have to work backwards here. So on top here I see -2, but on top here I see +2. I want them to kind of look the same. So I'm going to take that negative down to the bottom, and I get this. And then I distribute that negative inside the bracket to get this. And now I can read off my graph, compare the old one to the new one, and x change to -x. And when x changes to -x, that is the rule for reflection over the y-axis. So pretty complicated to see this one, quite a tough question. And your 1 mark just comes from reflection over the y-axis, the correct description for the transformation.